the sinusoidal functions sine and cosine. Sinusoidal means they go up and down the x-axis. So you have the amplitude here, and amplitude is the distance between the midline and the highest peak and the lowest peak of the graph. You can actually find it by means of that number you are adding to the function. Since I don't have a number added to the function or subtracted to the function, the midline is y equals 0. To prove that, of course, we can graph the function. And remember that our mode is always in radian to graph it, not in degrees. So you have y equals 3 sine, okay, 2/3 x. And as you can see, the graph is this, and the midline is y equals 0. So that would be the line that will cut your graph into two. So you have the amplitude, that's the distance between the midline and the highest peak of the graph, and that's actually 3. Now, from the equation, you will see that this number will be that. And remember that the amplitude is always positive. This is only negative when it's reflected, but the amplitude remains to be that number, the absolute value of which the number in front of your function. Now, the maximum, from the graph itself, you would see that the maximum is 3, and the minimum is -3. And you should be able to find it by thinking that the maximum value of any sine function, however small, however big the angle here, sine is an increasing function. It means that the maximum value of that function, including sine, is 1, and the minimum value is -1. Therefore, to find the maximum or minimum is to multiply the function or replace the function with 1 and -1. The whole of it, replace it with 1 and -1, you have 3 and -3. This is higher, so it's going to be the maximum. This is lower, so it's going to be the minimum. Therefore, the range would be the maximum to the minimum value, that's -3 to +3. So it means the values of y cannot exceed 3 and -3. Okay, now from the graph, you should be able to find the period too. This is a sine function which starts from 0, that's its first critical point. And one period or one cycle of a sine function will have to have 5 critical points: 1, 2, 3, 4, and 5. So therefore, our period should be 3 pi. Now let's prove that it's really 3 pi. So what should we do? You have 2 pi over b, and b is 2/3. Regardless of whatever you add to it, it's 2/3. So therefore, 2 pi over 2/3 is, when we reciprocate this, because we're dividing fractions, it's going to be 2 pi times 3 over 2. Okay, and then cancel it. And you see, through enough, our period is equivalent to 3 pi. Okay, now let's go to the next example. Now, this is a translated graph and at the same time a reflected graph. So again, if we graph this function y equals -4 cosine pi over 2x. Okay, plus 3. Okay, so as you can see, this is the graph. And of course, our amplitude is 4. Our midline is y equals 3. It's just that number you have added to the function. As you can see, if I will put y equals 3, it will surely divide your equation into 2 equal parts. So even if without graphing it, you should be able to get the midline by means of that standalone number in the function, which is actually the vertical translation of the graph. So y equals 3. The maximum from the graph, you would see that it is 7. And the minimum is -1. Those are supposed to be the values of your y, not your x. Okay, because the domain of these will be from -infinity to +infinity unless you will be restricting the values of your angle. So, the range now would be from -1 to 7. You can also find the values even without resorting to the graph by replacing cosine with 1 and -1. Okay, and here you have -1 and here is +7. Okay, the reason why I don't assume that I'm going to plug in 1, it should be the maximum. That's not the case. You still need to find which is higher. 7 is greater than negative 1. So therefore, 7 is the maximum and minimum is negative 1. Now, to find the period, regardless of whatever you are adding in the function, is to identify its b, which is pi over 2, and then divide it from 2 pi. So from our graph, this is a cosine function and the whole cycle is one curve. From here, this is the first critical point, second critical point, third and fourth, and the fifth will give us the period which is equivalent to 4. So therefore, we are expecting 4 here as an answer. So that would be equivalent to 2 pi times 2 over pi. We will cancel pi and 2 times 2 is 4. That's the reason why you have here as a 4. Remember, to find the period is to look at the one cycle of the function. This is one cycle of a sine. It's one curve. And find the last critical point of the graph. Okay, so the last one. So again, when we graph this, you have 5y equals 5 sine 5x minus 9. Okay, from the graph, you would see that our highest point is negative 4 and our lowest point is negative 14, because you see, if I will do it negative 5 times 1 minus 4, negative 5 times negative 1 minus 9, minus 9, you will have here negative 14 and you will have here negative 4. And negative 4 is greater than negative 14. So that's why you have here negative 14. The amplitude, as you can see, it's 5. From here to here is 5. It's just this number beside your function. And of course, the midline is negative 9. Okay, it's just the number you're adding to the function, whether it's in the front or whether you place it in the y equals negative 9. Whether it's in the front or you place it in after the function. So the midline is y equals negative 1. So making our range from negative 14 to negative 4. And then, of course, our period is 2 pi over b, which is 2 pi over 5. And that would be that number. You can find that by means of, if you're going to zoom the graph, I'd like you to see it. Okay, this is a sine function, so it's going to be 1 to up to that. Okay, it's 2 pi over b. Okay, so that would be where you find the periods. It's going to be from here, and one cycle is that.